Okay, this is practice midterm number 2 and problems 24 through 31. For all of these problems, you are to select the response that best describes what will form when the given pair of compounds is placed in water. And the options you have are A, one gaseous compound and one soluble compound. Option B is one gaseous product, while one of the pair, an insoluble compound, dissolves. Option C is one insoluble compound, one gaseous compound, and water. And D is one soluble compound and water. And E is one insoluble compound and one soluble compound. Again, I want to emphasize we're to pick the option which best describes what occurs when we place these compounds in water. And so now, let's start with the first one, number 24. This pair is HBr, which when placed in water is hydrobromic acid, and potassium sulfite. Okay? And so the first question you have to ask is, are these soluble? So we check the solubility rules, and hydrogen bromide is indeed soluble in water for hydrobromic acid. And the option, and the second of the pair is potassium salt. It doesn't matter what the anion is, it is going to be soluble in water. So we know that we don't have to worry. We've eliminated anything involving an insoluble compound from the running on either end. Well, for the one insoluble, while one of the pair, an insoluble compound, dissolves. That's not going to be the case. We know they're soluble before we place them in water. So I place them in water. Now I'm going to have to look. The same old strategy we've employed all along. Look at the inner pair and the outer pair, and we're going to look for either a neutralization reaction or a metathesis process. And I've got a hydrogen ion and a sulfide ion. Well, when I see a hydrogen ion, I look for one of the 7 anions present in the 7 net ionic equations for the neutralization reactions, and sulfite's one of them. With sulfite, I'm going to end up getting sulfur dioxide gas plus water in a reaction. And then I'm also going to get, now I'll look at the inner pair. This is a soluble pair. So potassium, it doesn't matter what the anion is. It's a potassium salt. So I'm going to get that plus potassium bromide. So what would I say? This is going to be forming a gaseous product and a soluble product, because this is going to be plus potassium, which we would write as equated. Now I haven't bothered to balance it. I don't need to balance it. I have enough information now to answer the question. I've got a gaseous product and a soluble product. So which option is that? One gaseous compound and one soluble compound. Well, that turns out to be option A. So you would fill in, there would be an A, B, C, D, E. You would fill in the bubble for A. And on your Scantron, you'll just fill in that bubble. And on the test, you would write an A. Okay? So I would write an A somewhere. Okay, now, the second one, I've got in water, this is hydrobromic acid, and this is strontium carbonate. Well, this strontium carbonate, we have a rule for a solubility rule for carbonates. Carbonates are insoluble. So I've got one of this pair is insoluble in water. So if I place it in water, it's going to sink to the bottom. Now, hydrogen bromide, or when water, is hydrobromic acid. When I add hydrobromic acid to that solution, what's going to happen? So now again, I'm going to look at the outer pair and the inner pair to see what's going to happen. And this is similar to the first problem. I've got a hydrogen ion, so I look at the outer pair, the anion, and that is a carbonate ion. Well, carbonate ions are one of the 7 neutralization reactions, one of the ones that evolves gas like the last one. So I know it's going to give me CO2 gas plus H2O, water. That's a liquid. Plus, and now I look at the inner pair, and I've got strontium bromide. Well, this is going to be soluble because the rules for bromide, most halogens, or most halides are soluble, and the exceptions being in silver +1 salts, the lead +2 salts, and the mercurous ion salts. And that strontium doesn't fall in one of those categories. So that means I'm going to get also strontium bromide aqueous. It's soluble. So now, what best describes this? Well, here I've got a gaseous product, while one of the pair, an insoluble compound, that would be the strontium carbonate, dissolves. So that is a feature that is definitely distinguishing it. This is going to be option B. So you'll fill in the bubble for B on your Scantron and write a little B by it on the test. Okay, now for number 26, erase this. I'm going to do the same thing. I'm going to look at the outer pair and the inner pair. Now, I've got a hydrogen ion again. So I look over here at the nitrate, and the nitrate is not one of those neutralization reactions. It's not one of the anions in any of the 7 neutralization reactions. So now I'm going to consider terms of solubility. All nitrates are soluble, so well, the hydrogen ion is soluble. So that takes that option off the table. Now let's look at the inner pair. I've got sulfate and barium. Well, sulfate, the rules say that sulfates are soluble. The exceptions being calcium, strontium, and barium. Those salts, those sulfate salts, are insoluble. That's barium sulfate. So that's one of the exceptions. So I already know I'm going to get barium sulfate, and it's going to be a solid. Plus, and then the outer pair, we know is soluble. It's going to be 2 nitric acids, and that's in solution. So now, what best describes this? This would not be A, certainly not B. There's no gaseous products involved. C, 1 insoluble compound, 1 no gas there. D, 1 soluble compound in water. Well, no, I don't see that. E, 1 insoluble compound and 1 soluble compound. So this would best be described by that option. So on your Scantron, you fill in a little bubble for E, and on the test you'll write a little hard copy E by that problem. Okay, now number 27. Again, we look at the outer pair, we look at the inner pair. And first I check to make sure both are soluble. Well, the first one is sulfuric acid. It is soluble in water. The next one is a potassium salt, so it doesn't matter. They're both soluble in water, so I don't have any insoluble starting materials. Now, I look at the outer pair. I have a hydrogen ion, I have a hydroxide ion. Well, when I have a hydrogen ion, I look for any neutralization reactions. This is the hydroxide ions, the most common neutralization reaction in practice, and that is hydrogen ion combining with a hydroxide ion to make a water molecule. So I know I'm going to get H2O liquid. That's going to be my neutralization product. I've got an acid-base reaction. Now I look at the inner pair for an insoluble combination. Potassium salts are all soluble, so I know I'm going to get plus potassium, and that's aqueous. So that's soluble. So in this case, what I've got is one soluble compound and water. Oh, option D, one soluble compound and water. So that's going to be a D. I'll fill in the bubble for D on my Scantron and write a D hard copy on it. Now, the next one, the pair we have is zinc sulfide and hydrochloric acid. Well, my solubility rules reveal that indeed sulfides are insoluble. The only exceptions being the group 1A salts, the ammonium salts, and calcium, strontium, and barium again. Those sulfides are soluble. So, but I know this zinc is not one of those. So this is insoluble. So one of the pairs is insoluble up front. I have an insoluble starting material, and the other is hydrochloric acid. Now I need to start comparing the inner and outer pair to see what happens. Now, I look at the outer pair, zinc and chlorine, or zinc and chloride, and I don't have a rule for zinc, but I have a rule for chlorides, and they're soluble except in the presence of silver ions, lead +2, and mercurous ions. So that's not zinc. So that means zinc chloride is going to be soluble. Now I look at the inner pair. I have a sulfide, which is wretchedly insoluble generally, but I've got a hydrogen ion. A hydrogen ion is revealing. That means I got to look for the neutralization reactions, and sulfide is, I think, the 7th one in our list of neutralization reactions. The sulfide ion is going to combine with a hydrogen ion in a neutralization reaction that is going to give me hydrogen sulfide gas. This is not one we want to do in the lab because this will kill you, but in small doses it just stinks. Okay, so we've got hydrogen sulfide gas, and there is no water produced in this case, but the other compound is going to be zinc chloride, which we've already determined is soluble. So I've got another one that is going to be one gaseous product while one of the pair, an insoluble compound, dissolves. Which one was that? Well, one of the pair. This is option B again. So you fill in the B bubble and put a B on your hard copy test. Now, the next one we have to deal with, number 29, is sodium carbonate and hydroiodic acid. I like to refer to it as high because it's a very friendly sort of a sound. Now, we have to check the solubility. Carbonates are insoluble except in the presence of group 1 cations, so sodium salts are soluble. So sodium carbonate is going to indeed be soluble, and hydroiodic acid is again soluble. So we don't have any insoluble starting material. Now we look at the outer pair and the inner pair for insoluble combinations or neutralization reactions. And I have, well, sodium, all sodium salts are soluble, so I've done looking for the outer pair. The inner pair now, I've got a carbonate ion. Carbonates are wretchedly insoluble. But I've got a hydrogen ion. Hydrogen ion, again, I have to look for a neutralization reaction. And carbonate, we already know, is one of the anions in the neutralization reaction. So I'm going to get carbon dioxide gas plus water, liquid, plus, in this case, it's sodium and iodide, so it's going to be sodium iodide. It's a 1-to-1 salt, and that's aqueous. We're not balancing these. This is scratch paper stuff over here. But I've got enough information to now answer the question. I've got a gaseous product and a soluble compound and water. Which one of these, gaseous gaseous compound and one soluble compound. I've got a soluble compound in water, but the gas is a feature that I would think is something we can't ignore, so I would take option A as the best descriptor. And so option A is one gaseous compound and one soluble compound. I put an A on the hard copy test, fill in the bubble for A on the Scantron. Now, number 30. First I have to check the pair. It's silver nitrate and sodium chloride. Silver nitrate is soluble because it's a nitrate salt, and sodium chloride is soluble because it's a sodium salt. So both of the starting materials are soluble. Now we're going to check for possible insoluble combinations and or neutralization reactions. Well, I don't have a rule for silver, but I do have a rule for chlorides. The chlorides are, most chlorides are soluble, the exception being in the presence of silver plus 1 cations, it's going to form a precipitate. It's going to form the insoluble silver chloride solid. And now we look at the inner pair. I've got a sodium ion, and I don't care what the other ion is. I know all sodium salts are soluble. And I've got a nitrate ion, and I don't care what the cation is because all nitrates are soluble. So we know it's soluble, plus sodium nitrate, which is soluble. So what best describes this? I would say one insoluble compound and one soluble. Option E, I think better describes it. There's no water produced, there's no gaseous products produced. And so that would be option E. And fill in the bubble on the Scantron. Now number 31, the last in this series, is the pair is ammonium carbonate and calcium nitrate. Okay, I've got to look to check, are those all soluble? Well, rule number 1 in solubility is that all ammonium salts are soluble, so I don't care what this anion is. This is soluble. Now, calcium nitrate. Well, rule number 2 is that all nitrates are soluble and acetates are soluble, so I know that this is going to be soluble, so I have no insoluble starting material. Now I want to look at the inner and outer pair. I have to erase this to fit it in. The outer pair and the inner pair. And I'm going to, in this case, I've got ammonium nitrate. Well, this is basically rule number 1 and rule number 2 in solubility. Those are soluble, so that goes without saying. Now I've got carbonate and calcium. I have a rule. I don't have a rule for calcium, but I have a rule for carbonate. We do see calcium in some of the exceptions, but carbonates are insoluble except in the presence of ammonium salts or group 1 ions, or there is no calcium exception there. So calcium carbonate is insoluble, which is good news if you're a shellfish, because most seashells are made out of calcium carbonate. It wouldn't last as long in water if they were soluble. And so that means I'm going to get calcium carbonate as a solid, plus, and I already know, the ammonium nitrate. It's soluble, rule number 1 and 2, plus ammonium nitrate. And that's aqueous. So that means I've got one insoluble compound and one soluble. And that was option, I believe, E. So, fill in the E bubble on the Scantron and make a hard copy E on the test. Get a duplicate record, and that is